So one final piece that's sort of related to all of this, but not really specific to any of the techniques that we use, but will help you as you start working on different types of problems, is a concept known as degrees of unsaturation. So when we think of things as saturated or unsaturated, that's a reference to the ratio of carbons and hydrogens primarily. So when we say a molecule is saturated, that means it has the maximum possible number of hydrogens given all of the other atoms that it has. So when we have a chemical formula, we can calculate the degrees of unsaturation as being equal to 2 times the number of carbons plus 2 plus the number of nitrogens minus the number of hydrogens minus the number of halogens divided by 2. Now, what is a degree of unsaturation? A degree of unsaturation is a pi bond or a ring. So if a molecule has 1 degree of unsaturation, that means that molecule has 1 pi bond or 1 ring. If a molecule has 2 degrees of unsaturation, then it could have 2 rings. It could have 1 ring and 1 pi bond, or it could have 2 pi bonds. So let's look at a couple of examples. So C6H14. We can see here doesn't have any pi bonds or rings. And if we calculate the degrees of unsaturation, we take 2 times 6 plus 2. So that's 2 times the number of carbons plus 2 minus the number of hydrogens, and we don't have to worry about the nitrogens or halogens. Divided by 2 equals 0. Whereas if we take 2 hydrogens away, C6H12, we get 1 degree of unsaturation. And so that could be something like a 6-carbon molecule containing a ring, or a 6-carbon molecule containing a double bond. If you ever end up with a large number of degrees of unsaturation, that's a pretty good sign that you've got an aromatic ring, because an aromatic ring, if you think about it, is a ring plus 3 pi bonds. So this molecule, styrene, is C8H8. We get 2 times 8 plus 2 minus 8 over 2 is 5. And finally, the most important piece of this to note is that, interestingly and maybe surprisingly, oxygen doesn't influence our degrees of unsaturation. So if we have this C3H8, 2 times 3 plus 2 minus 8 divided by 2 is equal to 0. If we add an oxygen to that, we have C3H8O. 2 times 3 plus 2 minus 8 divided by 2 is equal to 0. And so we can see that adding that oxygen doesn't change the unsaturation. So when you're working on coming up with a structure, if you have a chemical formula, calculating the degrees of unsaturation is often a good place to start. Because it will tell you whether your molecule has pi bonds or has rings.